Hey everyone, so I hope you did well on your methods exam too. I just actually got some time today to do it, had a pretty busy day yesterday. But anyway, let us get started. So this video is just gonna be MCQs and we'll be moving on to the short answer in a bit after I finish uploading this video. But yeah, this is my first time having a look at this paper, haven't had a good look at it, so let's see how we go. Alright, so question number 1, the asymptotes of the graph y equals to this r. Okay, so log function has a vertical asymptote, no horizontal one, so just a would be good. Okay, a function has a derivative, okay, this, and given that g0 is 5, find the value of g2. Okay, very well, so let us define this. Define, oh whoa, put my caps lock on. Define dg of x is equals to x to the power of 3 minus x. Integrate this, so dg of x, okay, plus c, so then our, what was it, so x equals to 0, so our c is gonna be just 5, so let's put that back in, so c is equals to 5, and define g of x is equals to that, so g of 2 is what we are finding. There we go, so g of 2 is just going to be 7, so answer is going to be D. Okay, so question number 3. A discrete random variable x is defined using probability distribution below, where k is a positive real number. Okay, find probability that x is less than 4 given that x is greater than 1. Okay, so we'll draw a number line, so probability that x is greater than 1 is going to look something like this. And probability that x is less than 4 is going to look something like this. So basically we are finding the probability over here. This is the intersection part. So this is equivalent to saying probability that probability that 1 is between, okay, x is between 1 and 4 I meant. Wow, okay, x is between 1 and 4. And probability that x is greater than 1. Okay. So probability that x is between 1 and 4 is simply going to be these two added up together. Because this is a discrete probability question, we don't consider the 1 and 4 here, so they are excluded. So on top we'll have 8k, and on bottom we'll have everything that's bigger than 1, so just these added up. So that is 5 plus 3 8 plus 2 10 to 10k, which is simplifying to 4 on 5. So option C. Okay, perfect. Move on. So question number 4. Okay, so we have our integral a to b is this, a to c is this, then find this. Okay, cool. Let me just quickly plot a rough graph to maybe use to visualize. So maybe this will do. So this is a to b and this is c. So a to b is -5 and a to c is 3. So the whole area is going to be 3. So if we can find this area over here, we can find what 2 times of that is basically. So here is our expression essentially, which is that area of a to b f of x plus area of b to c f of x will give us area underneath a to c f of x dx. So basically we have to find this part over here. Everything else is just given. So a to b we have -5 plus, I'm going to call this as x, so plus x, and then that is equal to 3. So our x is going to be 8. So integral from b to c of f of x dx is going to be 8. And we have to find 2 times of that as required by the question. So our answer would be just 8 times 2, which is 16. So option B. Okay, cool. So consider the functions. Okay, f for this domain, which is a quadratic like so, and g of x like that, to find the range of the composite function. Okay, so let us quickly first make the composite question table. So we have f of x and g of x, then we got the domain and range. Okay, so f of x domain is 1 to infinity, and this is just r. Okay, so let us quickly find out what the range of f of x is, because there may be a turning point in between. So I'm going to define another function. Define f of x is equals to x squared minus 4 times x. Oh yeah, another key part is that sometimes CAS actually chokes up. So like, it's best if you add multiplication sign. I know this is a bit too late to say it, but just for future, maybe for your special exam, just add a multiplication sign, because sometimes CAS is a bit fiddly, and if you don't add it, it will consider 4x as one variable, which kind of stuffs up the answer. So please make sure you add the multiplication sign to make sure your answer is correct. Okay, anyway, so we have a function f min, which will tell us, so f of x comma x. So this is the x coordinate where the minimum of this, or the absolute minimum of this graph or the function will happen. So f of 2, so minus 4. So our range for f of x will be minus 4 all the way to infinity, as this is a positive quadratic. And for this one, let us just quickly graph this. So if I were to define g of x is equals to e to the power of minus x, and g of x, okay, there we go. So it's going to be 0 excluded to infinity. So 0 to infinity is going to be our range. So 0 to infinity. Okay, now how you normally do this question is that first we are inputting something in our, so first we are inputting something in our f of x, right? So what I'm going to do, I'm going to draw a line, and I'm going to consider f of x as another function and g of x as another function. So this is our f of x, this is our g of x, okay? And I'm inputting a domain of 1 to infinity, which is spitting out a range of minus 4 to infinity, and that is going right into g of x, okay? So we have to, if g of x has a domain of this, basically what is going to be our range? Well, so that is going to be pretty simple. We just substitute g of minus 4, which is e to the power of negative 4, which is e to the power of 4. So our range is simply, our range is simply going to be 0 to e to the power of 4, right? Like that. And of course it's going to be included because, well, negative 4 is included, of course, so D. Okay. Hopefully that made sense. So question number 6, consider the function f of x with the domain this. The inverse of f of x is. Okay, so we'll define this on CAS first. So define f of x is equals to 2 times x plus 1 divided by 3 minus x. Yep. Okay, so I'm going to quickly expand this as well. And what I'm going to do is I'm going to solve for the inverse now. So how do we solve for inverse using CAS? F of y is equals to x, and then we are finding y again. This is what we basically do when we are finding the inverse, right? We switch x and y and then solve for y. So that's what I exactly did. Okay, and if I were to expand this function, so okay, so that is our inverse function, okay? And what is our domain? So domain is the range of the actual function itself. So what was our function? And I'm going to expand. Okay, so our range is, for this function, is basically anything but minus 2. So option A does have the correct inverse function, but it doesn't match the range, or the domain of the inverse is incorrect. The rest of them, they are just, yeah, incorrect. So our answer is going to be B for this one, because it has the correct domain for f inverse, which is the range of f. So yeah, and the function itself is correct as well. Alright, so moving on to the next one. So a fair 6-sided die is repeatedly rolled. What is the minimum number of rolls required so that the probability of rolling a 6 at least once is greater than 0.5? So our probability of success is 1 on 6, and probability that x is greater than or equal to 1 is 0.5. So that is same as writing probability that x is equals to 0 is, oh sorry, greater than, what am I doing? Greater than. greater than 0.5. Okay, so this will in turn give us probability that x is equals to 0 must be less than 0.05. And now we just simply use these numbers to get the right answer using the binomial distribution. So let us menu 5, 5, and A. So number of trials, we have to find that. So let's just try from 18 I mean. So we are going from option D to option A because that's how usually VCAA does it. So the options is usually between the bottom one. So it's either C, D, like high chances. Back in my days, we had option E as well, so we had to try that. But anyway, let's start with option 18. Probability of success is 1 on 6. And X value is going to be 0. Okay, so is less than that. 0.05. If I put 17. So that, if I put 16. 0.5. So I think the answer for that is going to be 17. I mean 18 works too, but since we are asked for the minimum one, the best one is to go is for 17, as 16 crosses the range, but 17 is still within the range of it being less than 0.05. So I think that works the best. Okay, question number 8. Some values of functions f and g are shown below. Okay, the graph of this function, okay, the graph of h of x must have an x-intercept at. Okay, so we have f of 1 is equal to 0, f of 2 is equals to 4, and f of 3 is equals to 5. Same with g, so we have g of 1 equals to 3, g of 2 is equals to 4, g of 3 is equals to minus 5. Our f of x, the h of x is f minus g, and that must have an x-intercept. So for x-intercept, we have to have y equals to 0. So f of 2 minus g of 2 is 4 minus 4. So I guess h of 2 does the job. So our x-intercept is going to be at 2 and 0. Okay. At a year 12 formal, 45% of the students traveled to the event in a hired limousine. Okay. While the remaining 55% were driven to the event by a parent. So probability that they came in limousine is 0.45. And the remaining one, so probability that they didn't come in limousine is 0.55. Okay, of the students who traveled in a hired limousine, 30% had a professional photo taken. Okay, I think, and of the students who were driven by parents, 60% had their professional photo taken. Okay, given that a student had a professional photo taken, what is the probability that a student traveled to the event in a hired limousine? Okay, I think the best approach to this, from my perspective, would be to draw a tree diagram. So we have our L, which is probability that they came in a limousine, and that is 45%, so 0.45. And this is didn't come in limousine, so 55. Now we come to the photo, so I'm going to say photo taken as P. So of the students who traveled in limousine, 30% had a professional photo taken, so 0.3, and the rest didn't, so 0.7. So, and the students who didn't come by limousine, 60% had their photo taken and 40% didn't. So now we are basically finding, given that student had professional photo taken, what is the probability that student traveled in a limousine? So probability that they traveled in limousine given that they had their professional photo taken. So that is going to be probability of L intersection P divided by probability of P. Okay, so probability, so this over here is simply following the tree diagram branch, so probability that L and then P. So this is the branch that we are looking at. So we will have 0.45 times 0.3. And probability of having their professional photo taken regardless of them coming by a limousine or not. So that would be 0.45 times 0.3 and then plus 0.55 times 0.6. So our probability of photo taken is going to be 0.45 times 0.3 plus 0.55 times 0.6. Okay, so let us quickly input all of that in CAD. I'll just quickly write this down. Plus 0.55 times 0.6. Okay, let's input this in CAD real quick and see what the answer has to say. So 0.45, 0.45, there we go, times 0.3 and 0.45 times 0.3 plus 0.55, 0.6. Okay, so 0.290. So our CAS gave us 0.290. Okay, so we have a lot of fractions. So let's start from option D again to get into a decimal format. No, it doesn't match. Yeah, okay. So 9 on 31 is the answer. Alright, so option C. Okay. Suppose a function f with this domain and its derivative this are defined and continuous on the domains. If f dash of 2 is less than 0 and f dash of 4 is greater than 0, which one of the statements must be true? Right. Okay, so I can clearly remove option C and can also remove option D because a local minimum can occur between 2 and 4 exclusive. So like it could be at 2.5 and that would still be valid. F does not have an inverse function. F is strictly decreasing on 0 to 2. Okay, let's quickly like maybe plot a parabola to help us out here. So if I were to just do that, and I'm gonna call this as f of 2. Okay, you know what, I'm gonna maybe say we take x minus 3 whole squared as our parabola to do this question. Maybe it's a valid function. So our domain is from 0 to 5. Okay, you know what, I'm gonna plot this on CAS and see how we go. So define f of x is equals to x minus 3 whole squared. Okay, so I'm gonna remove this window. Okay, so f of x, and we plot with the domain specified. So 0 less than x or less than 5. Okay. Okay, so yeah, so I think it's the inverse function that it wouldn't have because this is the way I've drawn it, right? So if, for example, we had something like this drawn, like, you know, from 0 to 2, like, again, it's not, like, you get what I mean, right? No, it's like, it's not necessarily has to be decreasing on 0 to 2, so that is out as well. Yeah, I think the best one is does not have an inverse. Yeah, I'm just gonna go with that because even if we go for a parabola like we drew before, it's gonna be like this. I mean, excluding this part. So it's gonna be starting from here and going here. So yeah, it's not a one-to-one function for a certain range, for a certain domain. So I think I'm gonna go with option B for this. Interesting question. Okay, so 12 students sit in a room with 7 students in first row and the other 5 in the second row. Okay, 3 students are chosen randomly from the class. The probability that exactly 2 of the 3 students are chosen in the first row are. Okay, so we'll have to use binomial for this. So our probability of success, actually, let's write that down first, are chosen in the first row. So 7 sit in the first row, so 7 on 12 is our probability of success. And we want exactly 2 out of 3 students. So we can say probability that, so we'll have probability of first, second, first plus probability of first, first, second, or probability of second, first, first. So, okay, in short, to not go through each of the combination, we can just use the NCR for this as 3C2, so number of, so NCR, yep, and then times it by probability of success to the power of the R value, so 2 times 5 on 12, and this should hopefully give us our answer. So let's simplify this on our CAS. Okay, let me close this one off. That was an interesting question though. Okay, so NCR 3,2, so 3, okay, so 7 on 12 to the power of 2 times 5 on 12, so 3 times that. Okay, so 245 on 576 appears to be the correct answer here. Okay, wow, they left the whole page blank. Okay, anyway, so we got a graph here. Which of the following best represents the graph of this? Okay, it's definitely not going to be C and D because the graph is meant to like shrink and not expand. So that is definitely out of the picture, which is good. Now, so first it will shrink, so it will land somewhere here. So it's shrinking twice, so this will land here, so this point will come here like this, and then we are moving a slight bit to the left again, so it's like 2x plus 1 equals to 0, so x is equals to minus a half. So after after shrinking to 1, it will move like here somewhere, like so. So I think it's gonna be A for this. Yeah. Okay, cool. The function this is mapped onto the function g with the following sequence transformations: dilation factor of 3 from y-axis, translation by 1 unit in the negative direction of y-axis. Okay, the function g has a local minimum at a point with the coordinates this. Okay, so f is this, and then after following these transformations, it's now g. So rather than actually applying the transformations to the whole function, what I'm going to do is I'm going to find the minimum local minimum first of f, and then just apply the transformations to that particular coordinate. I feel like that would save a lot of time rather than finding a new function and stuff. So let's just define this function on CAS. So define f of x is equals to x on 2 plus 2 on x. Oh, 2 on x, there we go. Yeah, okay. So we'll again use f min. Actually, better if you actually just plot it. Control I2 and then f of x, and our domain was given to be x is greater than 0. Okay, so our minimum point is somewhere there. So now if I do f min f of x, comma x, okay, it's giving me the wrong one. Alright, so yeah, we can just differentiate this. So menu for 1, so f of x, so solve that is equals to 0 comma x. There we go. So since our domain is 0 to infinity, we will take this into account. So f of 2 equals to 2. Okay, so our coordinate of local minimum for f is this, and now we have to apply the transformation. So supposing that we have x and y coordinates, we have to first dilate by a factor of 3 from y-axis. So this will become 3 of x, and then we have to translate 1 unit down, so y minus 1. So our final coordinates would be just substitute x and y with 2 and 2. So we'll get 3 times 2 and 2 minus 1. So 6 and 1 here is what I think the answer should be. Okay, cool. Let h be the probability density function for a continuous random variable where, okay, k is a positive real number and we have to find a probability. So not the value of k, but the probability of x is less than 0.5. Okay, so for that, let us quickly define the piecewise function. So we'll have, just go to here and here. here, sorry. And define f of x is equals to this. So x on 6 plus k, and then we define the domain, so negative 3 is yep, and then we have minus x on 2 plus k 0. Oh wait, this one is just less than, not equal to. Okay, 0 less than or equals to x less than or equal to 1, and this is just 0 elsewhere. So just gonna make sure I've defined it correctly, so that, yeah, and yeah, I have. Okay, cool. So now we have to find the value of k first. So let us integrate this. So to find the value of k, we have to, of course, we know that this is a probability density function, so the area between -3 and 1 is gonna be 1, because everywhere else is just 0, so it's like there will be no area for the other part. So between this -3 and 1, the area has to be 1, so that's our one condition that we can use to find the value of k. So menu 3, 1, and integral, so we have going from -3 to 0, and dx has to be equals to 1 comma k. Okay. Oh wait, -3 to 1, what am I doing? Wait, did I? Okay, I want to make sure I get this right. So -3 to 1. Why did I write 0? Okay, I think I might be tripping. Alright, anyway, so k equals to a half. Okay, so I think this is going to be our value for k. Sounds reasonable. And now I'm going to substitute that back in. So f and... Okay, now I'm going to define this function as g, just so that we have a raw copy of k if we ever need it again. And we have to find the probability that x is less than 0.5. So it's just another simple integral now. So -3, and this is going to be 0.5 g of x dx. So 0.9375. Can I get a fraction? Okay, cool. So 15 on 16. So option B. Okay, so the points of inflection of the graph, these are. Okay, so I guess this is just involving of solving double derivatives. So let's define this function first. So 2 minus tangent of pi times x, oh sorry, x minus 1 on 4, and 2 minus, so let me just quickly just see that we have defined it. Wow, okay, yeah, okay, cool. So defined correctly, and now we differentiate it twice. So menu for 1, well, there you go, and we differentiate it one more time because we are finding points of inflection. Okay, now we solve it for 0. Alright, so this is our value of x, where n1 is going to be k here in our question. So f of x, given that x is this, we get 2. Okay, so our CAS gave us 4k minus 3 over 4 and 2, where k is an integer. So this is out because k is minus, because the coordinate is different. Now this will simplify to k minus 3 on 4, which doesn't match any of the options, right? The only thing is that we are getting, because this is a trigonometric function, so it will have a reoccurring solution. So this is kind of like a general solution. Now, if I were to add k, if I were to put k as 1, we'll get 1 on 4. So technically, I can still express my solution as k plus 1 on 4, and we'll still be fine. So currently, option A is looking like the answer. Let's test option B as well. So k minus 3 on 4 has to be equals to negative 1 on 4, right? So we'll get k is equals to minus 1 plus 3 on 4, which is k is equals to minus 1 on 2, basically. So now k can't be 1 on 2 because it's an integer. So our answer is definitely going to be A here. Hopefully that made sense. Okay. Suppose that a differentiable function f and its derivative is this satisfy f4 is 25, f dash of 4 is 15. Determine the gradient to the graph of this as at x equals to 4. Okay, determine the gradient. So we have to find dy dx first, then find the gradient. So we have to first differentiate this over here. So we have to find dy dx. Okay, so for this, what I'm going to say is y is equals to f to the power of a half. So dy dx is going to be half times f of x to the power of negative half, and then times it by the derivative of f of x itself. Sorry. So we'll get f derivative of x over 2 f of x, 2 square root of f of x. Just want to make sure I've written it correctly. So yep, okay. So this is the gradient of the function y at any given point. Now we have to simply substitute x equals to 4 because that's the point that they're looking the gradient for. So we'll have f dash of 4 over 2 times f of 4. Sorry, f of 4. So we are given already. So f dash of 4 is 15 and f of 4 is 25. So 2 times square root of 25. So 2 times 5. 2 times 5 is 10. So 3 on 2. D. Alright. Question number 17. Okay, so we have the pseudocode here. Consider the algorithm below which prints the roots of the cubic polynomial. Okay, so define f of x, return this. So c is f of 0. Okay, if c is less than 0, then c is minus c. Okay, while c is greater than 0, which is the case for our one because 18 is greater than 0, print c, and if f of minus c is 0, then print this, and if c is c minus 1. Okay, cool. So our given options are, so we have to basically find the roots of this polynomial. Right. So then let us quickly define this function. So define f of x is equals to x cubed minus 2 times x squared minus 9 times x plus 18. Okay, so solve f of x is equals to 0 comma x. Okay, so our x is going to be minus 3, 2 and 3. So these are our roots that we got, minus 3, 2 and 3. However, we have to express it. The answer is going to be in a specific sequence because of these if conditions over here. Okay, our 2 is going to be at the very end because 3 is greater than 2 and we are depreciating the c value after we finish the loop. So first we'll get 3 and then we'll depreciate it to 2. Okay, if that makes sense. So 2 will be at the very end of the answer. And currently, so we know that f of 3 is going to be 0, and then f of minus 3 is going to be 0, and then f of 2 is going to be 0 again. Okay, so f of 3, so print c. So first root is going to be positive, so c is positive. So first will be positive, and then we have the negative root, so minus 3, and then we are depreciating it by 1, so c is now c minus 1, so 2, which is that. So our answer should be this, if I'm not wrong. So I think it's going to be option D. Okay. Find the value of x which maximizes the area of trapezium below. Okay, pretty standard question. So area is going to be half times a plus b times h. So, okay, we will find the value of h first. So h squared plus x squared is going to be 100, simple Pythagoras. So h is going to be 100 minus x squared, square root of that, of course. Now, of course, it can't be negative because, well, height can't be negative. So h is going to be the positive root. So now we just substitute that in. So half times x plus 3x, so 4x. So 4x times 100 minus x squared. So we'll get 2x square root of 100 minus x squared. Now we just have to put it in our calculator to find the value of x, not the maximum area, but rather the x value. So let's do this on CAS now. So define f of x is equals to 2 times x times square root of 100 minus x squared. Okay, now I'm going to try use the f max function, because this will give us an absolute answer. So f of x, which will find us the absolute maximum. Yeah, so x is equals to 5 root 2. Although, just on the safe side, what I'm going to do, I'm going to like quickly check for this actually. So apply to f of x. Okay, cool. And then menu for a. Okay, so yeah, okay, it's gonna be here somewhere. Yeah, so I was just checking in case if fmax is messing up, because sometimes it gives out weird answers like fmin that just did when we tried using that for the previous question. So better to check, but this worked. So 5 root 2. Okay, consider the normal random variable x that satisfies probability x is less than 10 is this and x is greater than 18 is this. The value of this is closest to. Okay, so for this, what I'm going to do, I'm going to just use the standard normal for this question. So z is equals to x minus mu over standard deviation. So 0. Oh, actually we have to find the value of z. So for that, let us actually use the inverse normal. So menu 5, 5, 3. Our area is 0.2. Enter. So our first area is this, and then our second area is going to be 0.8, because remember in CAS we are always looking at the left side. So even though x is greater than 18 is 0.2, we have to make sure that we are using the left tail, so 0.8. Okay, so these are our two standard normal values. Now we can just simply find the mean and standard deviation using this. So our first equation, so solve, I'm going to say we are solving a system of equation. Alright, so 10 minus, oh, should have added a 10 minus x on y is equals to negative of this, and then we have 18, again I forgot to add the fraction, 18 minus x on y is equals to Control C, Control V, comma x, comma y. Okay, so there we go. So this here is going to be our mean, and this here is going to be our standard deviation. So now we can just use what am I doing? Menu 5, 5, 2. So I'm just going to say 12. I'll adjust the mean and stuff later. So let us put this as 14, and let us put this as that. So okay, so the closest is 0.337. So answer is going to be C for this. Hopefully this made sense. Okay, the function has an average value k on interval 0 to 2 and satisfies this for all x real numbers. The value of definite integral is. Okay. Okay, that's fine. So the average value is going to be 2 minus 0. So 1 on 2 minus 0 to 0 to 2 f of x dx, and that is given to be k. So from 0 to 2 f of x dx, we'll have 2k. And this is a repeating function, so with a period of 2. So hang on, if I can actually make a function out of this. So we'll have 2 pi over n has to equals to 2. So then we'll have n is equals to pi. So if I were to do cosine pi x, for example, as my repeating function, and if I plot it, so define is equals to cosine pi times x, and if I were to plot it, add a graph g of x. Is it g of x or f of x? I forgot. Yeah, g of x. Okay, g of x. Okay. Well, unpin. Okay, there we go. Alright, so then if I were to do f of x plus 2, oh sorry, my bad, it was g of x, right? Not f of x. Okay, delete this graph. Delete. Come on. Okay, there we go. G of x plus 2. Okay, there you go. So it sits right on top of it. Okay, so now, so the area from here and here, so the area from 0 to 2 of this is gonna be the same as the area from 2 to 4 and 4 to 6, right? Because it's a repeating function, so it will have the same area. Yeah, okay, that makes sense. So in that case, this becomes quite easy because we can express this integral as 2 to 4 plus 4 to 6, and for each of them it's going to be 2k plus 2k, so answer is going to be 4k for this. Okay, I think, yeah, okay, so I'll do section B later. I hope you guys did well, and if I'm wrong with any of the questions, please let me know down in the comments. I'm happy to address, and thank you guys for watching. I'll soon upload the short answers, so stay tuned for that. Bye bye.